ECOS is the system I'm going to be talking about today. And so really, ECOS is designed to cope with an increase in the demands that we're placing on our handheld devices. Smartphones, e-book readers, all those kind of things. They are increasingly having applications that need a lot of CPU, a lot of energy. Speech recognition is a perfect example. And so the approach that's taken right now for some of these is it gets sent off to a Google server somewhere, or in Apple's case with their new iPhone, it gets sent off to an Apple server somewhere. So they're trying to find ways to how do we deal with this complexity. We're also potentially working with sensitive data on some of these devices, health records, your bank account information. And so you may not want everything that you say into your iPhone device to suddenly go off to an Apple server somewhere. And so application-independent offloading is an approach that we can take where we can have applications that normally are going to run within the confines of your device, but if you need extra resources, you need to save some energy, you can take some of that application and run it on another resource elsewhere, on a server or in the cloud somewhere, but sort of within the constraints that you have. And so Clone Cloud is a project from Intel that looks at offloading applications on Android devices. Maui from Microsoft looks at .NET applications. And Amazon's new Silk browser is another good example of offloading. Unfortunately, there's a couple roadblocks to all these sort of existing systems that make them not practical for enterprise networks and really even sometimes for home users. So one of the issues is privacy and trust. We're dealing here with potentially sensitive data that's going to be in your application. And as soon as we offload that application elsewhere in our network, we can leak data in transit or we can leak data on whatever resources we're on. And existing systems don't consider this at all. Resource availability. We potentially have a diverse set of compute resources that we want to be able to use, be it an idle desktop that happens to be in our network, a data center, or a remote cloud resource somewhere. And these resources are going to have varying ability and varying capacity to run applications. And lastly is scalability. So we have multiple handheld devices from different users. They're going to have different goals, either energy savings or performance improvements, and we need to be able to handle all these devices simultaneously to be able to provide some benefit to all of them. So in order to make offloading feasible for enterprise networks, we're looking at how can we actually go ahead and eliminate these roadblocks and develop a system that's going to make offloading possible at scale and in a secure environment. And so I'm using GENI to look at part of this problem, and the question is how do we assign offloads to compute resources such that we can provide as many benefits as possible to as many handheld users. And so again, as I mentioned, we're dealing with diverse users here and diverse resources, so we have varying goals. We have a limited set of trusted resources for each user. You may only trust friends that are within sort of your circle of people at your work, or you may trust anyone within your company to actually run your application. We have changing resource availability and diverse capabilities, and then there's also overhead associated with actually doing this offload. We need to transfer execution state from an application, and so the size of that execution state, the quality of the channel that we have between the phone and our compute resources is going to have an impact on that. And so the GENI resources that I'm actually using to sort of start to explore this is both Proto-GENI and OpenFlow. So for my demo today, I'm going to be, I have a couple Android emulators that I'll show you in a minute that are running at Wisconsin on a couple servers. But then the compute resources that they'll be offloading to are Proto-GENI node at the GENI project office and some nodes at Wisconsin, as well as it's going to go across to OpenFlow. And OpenFlow is going to give us the benefit that we can install paths only for offloads that we actually trust, and that adds sort of an extra level of security in there by having that default off approach. So with that, I'll switch over to my live demo here. So we have running here is an Android emulator, and we'll see the visualization in the back looks a little off. So let me see if I can actually bring it up here instead. We'll just do that. Okay. So here's a visualization that shows that we have our resources at Wisconsin and our resources at the GENI project office. And so when I go ahead and launch a sample application here, I'm actually going to have a chess game that's going to play itself. And so I'll go ahead and launch that chess game on a couple of these devices. And slowly, as these devices start to play chess against themselves, we'll see that we're going to have artificial intelligence moves happening. And we'll wait for, there we go. So one of them started to move. So now if I bring up my map here, we can see that Android devices are starting to offload their applications. And so the line's going to show which server they're actually using. And they're taking into a bunch of different things when they're making this decision. So first of all, the top 3 Android logos that you see there, they want performance improvements. And so we want to distribute them across as many resources as possible, because the less contention there is on a particular server, the faster that's going to run and the more performance improvements we're going to see. Then we have the bottom 3 devices want energy improvements. And so we're going to try to keep those devices on different servers that aren't on that don't have any of the performance-seeking devices on them. So as this visualization runs and these offloads are happening, you'll notice that no performance-seeking and energy-seeking device are ever going to end up on the same server together. And it's possible that there may not be enough resources in some cases. We may not have enough resources that are trusted or capacity available, and so some devices won't have the opportunity to offload, and that's what the flashing device is showing us. This device here is forced to run the application on its device, and it doesn't have that opportunity to offload. But because we haven't modified the applications in any way or pre-partitioned them in any manner, you can always do that. You can always still run the application on your device if you don't have an opportunity to offload. The last thing I'll point out here is sort of the security aspect of it. So I'll go ahead and bring up what the policy looks like here. And so we have the 3 servers at the top, and then 2 of the devices have limited devices that they trust. So our handheld 3 here and our handheld 6, they only trust particular servers, and those are the servers at Wisconsin. And so you'll, sort of as this visualization goes through, you'll notice that the 3rd device from the top and the device at the very bottom are never going to go to any other server because they don't trust that server at the GENI project office. They only trust the servers that are at Wisconsin. And so all these factors sort of get put into our central controller that's doing the scheduling, telling these devices where they can actually offload. So it's been great to actually be able to use the GENI resources and see how different environments and how different network quality links start to play a role here. And we're looking going forward at what other factors do we need to take into account? Do we need to take bandwidth into account? If we make a decision to offload and it turns out the server didn't have enough resources, can we somehow learn from that? So we're working on improving the system continually going forward to really make offloading feasible and possible for an enterprise.